Hi and welcome to Nav School, a series of lessons that will teach you simple, accurate visual navigation. Not only is this important for airmanship, it will also improve your awareness of what you're flying over and is the basis for navigation competitions. This first lesson teaches you how to plan effectively using ordnance survey mapping, although it is applicable to any other type of mapping or charts that may be available to you. And in the next lesson we're going to fly it and see how well we do. Accurate visual navigation relies on a well-drawn map with the pertinent information that you need to be able to get around your route. So let's start with the map. So before I start doing any precision planning, I use the Sky Demon Light website, there's also an app available, to identify what the local airspace, danger areas, airfields and NOTAMs are that might be affecting my flight. Today we're operating from near Reaver Hill glider site, and then we're then flying up to the northwest and then back towards Reaver Hill as we go through 3 turning points. So it's important to make sure we understand where Reaver Hill is and how we're going to avoid it. So now we've seen the airspace, we can move on to the Ordnance Survey map itself. I've drawn the airspace on already. You can see the large pink circle for Reaver Hill. And then I've added the 3 turning points we're going to be using today. The first is a small wood, the second is a small collection of houses, and then the third one is a road junction. I've then added the track lines, which are basically just the lines that join the turn points. That is the visual navigation line that we're going to try to fly directly over. So a really useful part of the drawing the line is to leave gaps where there's some pertinent navigation information underneath. So if it's near a road junction or a building or similar, if you just leave a gap in the line, it makes it easier to see while you're in the air. Next we add the fixed points. These serve 2 purposes. First of all, it's to make sure that we stay on the line, and they can also be used for timing, which we'll come on to later. Now fixed points, they should be big, they need to be able to be seen from a long way away, because the whole point of simple navigation is that you are looking several kilometers into the distance. So if you can see something from several kilometers away, you don't need to do any navigation between where you are and where you're going to. They should also be unique, so don't pick something that's easy to confuse. Don't pick a road junction if it's surrounded by lots of other road junctions, or a wood if it's surrounded by lots of other woods. You're really looking for something that's a standout item. And then finally, because we don't fly with a compass, what we're ideally looking for is something that will give us a sense of direction. So if you're aiming towards a linear feature, as you approach it you'll be able to get a sense of direction, and from that you'll have a good idea of what departure track you should be on to be able to regain or remain on your track. If you were flying, for example, to a circular wood, that would give you nothing. A decent road junction would give you an awful lot more. And then finally I just highlight anything else that I see that might be useful from the air but isn't necessarily a direct navigation feature. Churches are fantastic. They've usually got a tower or a spire. They really do stand out against the background when you're flying near towns. The other thing I do on a nav leg like this is, before I get to my turning point, I always put an arrow on which gives me an indication of what my next turn direction will be. So this is a really useful reminder as you're approaching a turning point to look for a feature on the ground that is directly below your track on your outbound heading. So that's the map sorted out for navigation. You should have your 3 turning points, the track lines, and then the fixed points that you're putting on there. So you could go and fly that now, but we're now going to add some timings on to make things easier. For that you need 4 key bits of information. You need the speed of your wing, the wind speed and direction, the track, and the distance to each of your timing features. So the first bit of information we need is your wing speed. I do this by using a GPS to record my average speed on an interwind and then in a downwind leg, making sure that I fly exactly the same track on both of them, and approximately a mile, but more is better because you're looking for an average. There's quite a bit of wind direction and speed change even over such a short distance. So in the example here, I recorded 71 kilometers an hour on the downwind leg and 31 kilometers an hour on the interwind leg. If you subtract the smaller number from the larger number, that gives you effectively double the wind speed. So divide it by 2 to give you the wind speed. So then once you've got your wind speed and you've got your average speed, you then either subtract or add the wind speed to your recorded speeds. Both of those numbers should come out the same. So in the example here, with 71 and 31, the wind speed acting on that was 20, which means that my airspeed in still air would have been 51 kilometers an hour, and that's on my Lunar 2 23 meter with the trims out. The good news is you only have to do this calculation once and you can carry it forward to all future calculations. So it looks a bit laborious, but it's absolutely critical information to allow you to plan anything cross country. So the next bit of information we need is the wind at the altitude we're going to be flying at. For this I use a website called windy.com. There's also a Windy app available, which is excellent. This gives you a full range of weather forecasting and reporting features on it, including the airgram, which is a really important one for us today. So let's look closely at that. So in this close-up you can see the time that we're due to go flying is in the evening, and the height we're going to be operating at is about 1500 feet, which on this Windy app is the second of the wind arrows. This is always in knots, so what you can see here is you've got an easterly wind because that's where the feathers are, so the wind blows from the feathers towards the thin end. Each long line is 10 knots and each short line is 5 knots, so we've got a wind, it's an easterly wind, so blowing from the east at 15 knots, which is 28 kilometers an hour. So we'll use that in our calculations. And then the final two parts of information we need are the distances and the track for the legs that we're going to be flying. So you can see there that leg 1 is a total of 9.4 kilometers, and we've got fixed points at 2.2, 4.6, 5.7 and 6.8 kilometers, and that's on a track of 307 degrees. And on the second leg it's a total of 6 kilometers with 3 intermediate fixes, and that's on a track of 160 degrees. So we'll take these forward into our calculations also. So now we've got all the information that we need, we can do the calculations. You can do this via a variety of methods. I'll make it really easy and we'll do an online one. So we'll do the first couple and it should hopefully make sense at that point. So the first thing we do is our course. We've already seen from the measurement that the first track is 307 degrees, so we'll put in 307. True airspeed, that's our wing speed, which we know for my wing is 51 kilometers an hour. The wind direction is 090 degrees, that's already in there, and the wind speed is 28 knots, so we put that in there. Ignore the things in the grey boxes here. The only thing that you need to look at there is your ground speed, so that will give you an indication of how fast you're going to be across the ground, and as you change your course that will change. So the next thing we need to do is to put in our distances. So the distance to the first fixed point is 2.2 kilometers. And that gives us an output of 1.89 minutes. So I'm just going to make a note of that. So we'll call it 1.9 minutes, and we'll come back to some jiggery pokery in a moment of how we sort that out. The next distance we've got is 4.6 kilometers. So we'll put that in. That returns, that's 3.95 minutes. And we'll just do one more, and that'll be at 5.7, which is our third fixed point. And that comes in at 4.89 minutes. So we'll stop there. Obviously it's exactly the same process for the rest of the fixed points that you've got and the turn points. I'll go off and calculate the rest. So I've calculated all of the leg timings based on the distances and the tracks that we've got. You'll see from what I've done here that I've added the leg 2 times to the times I had for leg 1, which then allows me to a single cumulative time that I'm running throughout. The other option would be to run individual timings for each leg, but you do have to remember to stop and to start the stopwatch again. The jiggery pokery I was talking about allows us to convert, for example, for the first of the fixed points at 2.2 kilometers, we've converted 1.9 minutes into 1 minute and 55 seconds. The easy way to do that is you just accept the whole minute, so the 1 is already in there, and then for the 55 seconds I've just multiplied 0.9 by 60 seconds, and then rounded it to the nearest 5 seconds, and I've done that for all of the turning points and the fixed points that we've got. So now we've done all the calculations, we'll just transfer that information across onto the maps. So we just put next to each of our fixed points the time that we're planning to be there. The other thing you'll notice is that next to the timings I've also written the distances down as well. This means that if I need to and I want to go and fly on a different day, I can just put a line through those timings, and it means I don't have to measure all those distances again. So we'll be starting off resetting the stopwatch at 0 and then flying along the first leg through the 1 minute 55, 3:55, etc., all of those fixed points until we get to the turning point at 8 minutes and 5 seconds. Just before that we get the indication that we need to turn left, so when we get to the turning point we'll be turning left and then following the next set of fixed points up the map until we get to our final turn point at 18 minutes and 45 seconds. The big aim of today is that as we're flying along, we'll work out if we're early or late, and we'll just carry the difference in our timings forward. We're not trying to necessarily be there at those points. It's very nice if we are, but if we're running early or running late, it just means that we know roughly what time we'll be at the next one of our fixed points or turning points. So in the next video we're going to go off and we're going to actually fly this route. So we'll take the map along and I'll put up a moving map display to show you where we are in the real world against what the video says, and I'll do some commentary of what I'm doing as I'm flying down the route. Hopefully we'll be able to find all the fixed points, hopefully we'll be able to find the turning points, particularly the first turning point we get to, which is just a small collection of buildings, but we'll be able to use our precision navigation and timing to make sure that we get there. So look forward to seeing you there.